Bismillahirrahmanirrahim. Assalamu alaikum. Today we are going to start a new topic under Physical Pharmacy 315 course number. The name of the topic is extraction processes. In this extraction processes, we are going to discuss numerous type of extraction processes, their purposes and their processes. The different types of extraction processes are maceration, percolation, liquid-liquid extraction, and large-scale extraction, of which we are going to do their purpose, why they are used, and the process, how they are done. So basically, in many pharmaceutical preparations, extraction is done before the preparation of the final product. These extraction is mainly done by the of the compounds or the materials which are naturally obtained. Means the extraction is mainly done, the compounds are mainly extracted out from natural products, but it's not necessarily that these processes are related to natural products only, but like liquid extraction, you will see that liquid extraction is somewhat different, and you can use is for the whole synthetic drug as well. So first we are going to start with maceration, or first we will see what is extraction process. First, we are going to see what is extraction as a process. What are the method of selection of extraction? Why we are using different types of methods? Why there is no one method of extraction, and why there are different types of extraction methods? And we'll particularly the interest of our main interest lies in maceration and percolation. These are two. There are other methods as well of extraction, but we are particularly interested in maceration and percolation because they are mostly used in the manufacturing of pharmaceuticals. So we require to know what is maceration and percolation preferably, but we'll see other methods as well. Extraction methods for preparing solutions. The sole purpose of such basic extraction procedure for crude drugs are to obtain the therapeutically desirable portion and eliminate the inert material by treatment with a selective solvent known as menstruum. Basically, what is the basic purpose of extraction is to basically extract out, or you take out, or you obtain the therapeutically active or desirable portion by some inert material. Why inert material? Because you don't want your compound to get interacted with the material you are basically treating it with. So the compound shall not change or shall not be changed into any other material, because of course for our desirable therapeutic agent should contain the desired therapeutic action. If the compound is not similar, then you cannot get the same desirable action. So you need to get the desirable therapeutic portion of that drug, which is required for that particular action. For that, you need an inert material. We treat our portion with an inert material and we extract out our desirable portion. With a selective solvent, the solvent which is used in this type of extraction or in extraction usually is known as menstruum. Certain pharmaceutical preparations are prepared by extraction, that is by withdrawal of desired constituents from crude drugs through the use of selective solvents in which the desired constituents are soluble. The certain pharmaceutical preparations are wholly, just say, for example, there are examples like peppermint spirit. In peppermint spirit, you can say that the extraction is done through alcohol, by using alcohol. So we basically dissolve out or withdraws our desired component, okay, from the crude drug, from the whole of the peppermint plant. We only we only extract out the peppermint and use it in our preparation. Type of extraction procedure plays a decisive role for the qualitative and quantitative composition of the extract. Basically, why we use, or there are different methods, and why they are important, because when you use a typical type of extraction procedure, this plays a very important role in the qualitative and in the quantitative composition of the extract. Because of that extraction procedure, the thing you are getting, the quality and the quantity both changes according to the extraction procedure you are using. That's why when you don't get these methods are found, because when you maybe someone only tried to take out their desired products with decoction. You know what is decoction, like, you know, making tea in the house. It's like that. Maybe when he or she did another test with a different type of procedure, they get more caffeine out of it than they had with decoction. So that's how different processes were made, because it exerts its action. I mean, it exerts its role in the qualitative, how much you are getting, and quantitative, that is how much you are getting, and qualitative means are you getting those compounds which are required in which quantity. So that determines why we are using different extraction procedures. The standardized extracts thus obtain a further processed for inclusion in other dosage forms, such as tablets, capsules, containing several groups of plant metabolites. The compounds which are taken out from through extraction, they are standardized. After standardization, they are basically incorporated or included, or they are used in the manufacturing of tablet, capsules, which has other plant metabolites as well. Not only plant, but can be synthetic as well. Because each crude drug contains a number of constituents that may be soluble in a given solvent, the products of extraction, termed extractives, do not contain just a single constituent, but rather varying constituents, depending on the drug used and the condition of the extraction. Basically, we are talking about the plant products from the plants. You know that plants do not contain only one component. They have several components, and certain times several metabolites they are present in there. So the extraction or the solvent which is coming out, which is basically coming out after dissolving all those desirable constituents, then the extraction or the product which is you're getting is termed as extractives, because it has many constituents in that, depending on the drug used in the condition. Tincture, fluid extracts, and extracts are the pharmaceutical products most commonly prepared from extractives. Basically, tinctures, fluid extracts, and extracts are prepared from extractives. So the main body is to extract out, and then it is incorporated into tinctures or fluid extracts to make a suitable pharmaceutical product. The solvent system used in extraction are selected on the basis of their capacity to dissolve the maximum amount of desired active constituent and the minimum amount of undesired constituent. What solvent you are going to use is determined by the compound you want to get maximum, and the undesired product should be minimum. So the compound which you want should be soluble and should be highly soluble in the solvent which you are using, and the undesired product should be least soluble in that, so that you don't get the undesired but only the desired compound. In drug extraction, the solvent to solvent mixture is referred to as the menstruum. I've told you earlier. in the earlier slide. And the plant residue, which is exhausted of active constituent, is termed as mark. So the remaining portion of the plant, the remaining part after the extraction of the constituent is known as mark. It is not termed as waste, but it is mark. Why not waste? Because waste is something which you throws, because you don't have anything important in that. So, but you are only collecting the desired component which you required. So you use that solvent in which that compound is desired and solubilizes. It takes away that. Then mark, it has, undesirable, which you didn't desire, but they are still important. So the mark can be treated again to get a new compound out of it. Okay. The selection of the menstruum to use in the extraction of a crude drug is based primarily on its ability to dissolve the active constituent. The selection of menstruum, that is the solvent which you are using, based on primarily on its ability to dissolve the active constituent, which the constituent you want to dissolve, you want to desire. The menstruum should be able to dissolve that compound in it. Although water and alcohol, and to a lesser extent glycerine, are probably the most frequently employed solvents in drug extraction. Acetic acid and organic solvents like ether may be used for special purposes. Mostly which menstruums are used? Water and alcohol, and to a lesser extent glycerine, and probably the most frequently employed solvents in drug extraction. Acetic acid and organic solvents like ether may be for special purposes. There are different methods: maceration, percolation, decoction, digestion, and infusion. We'll go into details of these later. Methods of extraction, once more, the principal method of drug extraction are those which are important in pharmaceutical preparations are maceration and percolation. What are the factors? Method selection. In selecting a particular method, what are the factors we should keep in mind? Number one is the nature of the crude drug. What is the nature of the crude drug? The drug adaptability to each of the various extraction methods, and interest in obtaining complete or nearly complete extraction of the drug. So these things should be keep in mind while selecting the extraction procedure. Now, how it is related? Character of the drug. How the character of a drug is related? If the drug is tough and hard, like nux vomica. Nux vomica is very hard. So if a drug is hard and tough, then we usually use the method of percolation. If soft and parenchymatous, like gentian, we use maceration. In unpowderable, such as quill, we use maceration. If an unorganized drug, such as benzoin, we again use maceration. If preferable to avoid powdering, such as senna fruits, then again we use maceration. Therapeutic value of the drug is the next consideration. When the drug has considerable therapeutic value, the maximum extraction is required. So that percolation is used, as in example is belladonna. When you required therapeutic value, your prime or focus is therapeutic value. If the drug has little therapeutic value, however, the efficiency of extraction is unimportant and maceration is adequate. For example, flavors like lemon or bitters, gentian. If you need a less therapeutic value drug, component, like flavors, lemon has flavor. If you're extracting only flavor, then maceration can also be done. Stability of drug. How continuous extraction should be avoided when the constituents of the drug are thermolabile. So stability of the drug is also very important to keep in mind. If you are dealing with a thermolabile compound, then the continuous extraction procedure should be avoided. Solvent. If the desired constituent demand a solvent other than a pure boiling solvent or an azeotrope, continuous extraction should be used. If we require a boiling component, a boiling solvent, then continuous extraction should be used rather than to keep it in a pure boiling form. Recovery of solvent from the mark. The residue of the drug after extraction, often known as mark, is saturated and with solvent, and if economic, the later is recovered. You want to recover, and this is a very good process. The processes which give you back the solvent is an efficient method. And always while you are extracting or doing anything else, the procedure, your procedure is efficient if you're getting if you are able to reuse your solvents which are you're using, then the method is termed as economical method or efficient method. Cost of drug. From the economic point of view, it is desirable to obtain complete extraction of an expensive drug, so that percolation should be used, like in ginger. For cheap drugs, the reduced efficiency of maceration is acceptable in view of the lower cost of the process. In particular, the cost of size reduction to a powder state is avoided, whereas this is a significant part of the percolation process. When we'll go into the detail of percolation, we'll understand this line more. Concentration of product. Dilute products such as tinctures can be made by maceration or percolation, depending on the previous factors which we have gone through. For semi-concentrated preparations, concentrated infusions, for example, the more efficient percolation process is used, unless the drug cannot be powdered or is not worth powdering when double or triple maceration is chosen. Concentrated preparations, of which liquid extracts or dry extracts are example, are made exclusively by percolation. The concentrated products of which liquid extracts or dry extracts are example, the one in which we get liquid extracts or we get dry extracts, with the exception that continuous extraction can be used if the solvent is suitable and the constituents are thermostable. Maceration. Now, steady state extraction. It is also known as steady state extraction. Term derived from Latin word macerare, meaning to soak. It is a process in which the properly comminuted drug, means the drug which is taking from the from where it is grown and to the market and then to the laboratories. So the process, it is the process in which when you have taken the drug properly, is permitted to soak in the menstruum until the cellular structure is softened and penetrated by the menstruum and the soluble constituents are dissolved. It is basically soaked until the menstruum, it reaches to the cellular structure by how? By softening and penetrating the compound, whatever compound you are, whatever part of plant or whatever the crude drug or whatever the product you are getting the constituent from. So what is basically maceration? Maceration is basically permitting your drug to soak in the manner and to so many days that the cellular structure gets softened and your menstruum penetrates in it and dissolves the soluble substance, and you can take that out. Okay. For drugs containing little or no cellular material such as benzoin, aloe, and tolu, which dissolve almost completely in the menstruum, maceration is the most efficient method of extraction. Benzoin, it is a resin. Aloe is basically is an it's juice, or it is from it is collected from the leaves of a plant, aloe vera. and tulu is also resinous material. For drugs like these, menstrual is maceration is very useful, because in maceration the drug is almost completely dissolved. So after dissolving the completely dissolved drug, you will get your desired component in maximum limit. Maceration is usually conducted at a temperature of 15 degrees centigrade to 20 degrees centigrade for 3 days, or until the soluble matter is dissolved. For example, compound benzoin is collected in this way, sweet orange peel tincture, compound cardamom, and tulu balsam tincture. This is how the flow chart you can say of maceration. What you do, plant material, you get a plant material, you cut it into small pieces. Usually you do that. Of course, if you have a plant material, if you have a plant part like resin, then you size reduce the resinous material you get. Okay, placed in a closed vessel with menstruum. Suppose standing with occasional shaking, you can shake with occasionally. Liquid strained off and clarified. The liquid is then strained off and evaporation and concentration is done. Modification of the general process of maceration. Repeated macerations may be more efficient than a single maceration, of course, because you cannot, you will not get, maybe you will not get the desired product if you are only soaking it for 1 or 2 or 3 days. Maybe, you know, after 3 days you soak it again, then you will get your desired product. After, you know, you are taking out the first batch of menstruum, then you again add some more menstruum, and then maybe your desired product will dissolve in that. Repeated maceration may be more efficient than a single maceration, since an appreciable amount of active principle may be left behind in the pressing, first pressing of the mark. What it is saying that maybe what I've just explained you, maybe in the first separation, you will not get your desired product in the maximum amount. So maybe in the second, you will get your maximum amount. The repeated maceration is more efficient in cases where active constituents are more valuable. And if your active constituent is a valuable one and you get it very scarce, its production is scarce, so scarcity is there. So you will, you know, try to get out the maximum product or at the active compound from there. So you do the double maceration, or you repeat the maceration. Double maceration is used for concentrated infusions which contains volatile oil. Example, concentrated compound gentian infusion, where the mark cannot be processed. A process of triple maceration is sometimes employed. The total volume of solvent used is, however, large, and second and third macerations are usually mixed and evaporated before adding to the first macerates. Because usually the first one is more, you know, it has more active constituents in them. This procedure, the use of the process for preparation containing volatile ingredients. In few cases, it is desirable to change the physico-chemical nature of the solvent during a single maceration process. Opium tincture is prepared by using change of physico-chemical processes or nature. Sliced, what we do while we are making opium tincture, we slice the opium, disintegrated in boiling water and left to cool for 6 hours. After that, we add 90% of alcohol is added to the cold mix and macerate for 24 hours. The addition of alcohol prevents the formation of gummy marshal in the final product. Basically, why you add 90% of alcohol is because when you slice opium or when you macerate opium, you know, there is a byproduct is formed, or the gummy portion in the opium, it also dissolves. So it prevents that gummy marshal. Circulatory extraction. What is circulatory extraction? The efficiency of extraction in a maceration process can be improved by arranging for the solvent to be continuously circulated through the drug. We can improve the process of maceration. How? After we basically the solvent which is coming out should be continuously circulating. If you are able to, you can circulate the solvent, then your process will become more efficient. Solvent is pumped from the bottom of the vessel to the inlet where it is distributed through the spray nozzle over the surface of the drug. The movement of the solvent reduces boundary layers and the uniform distribution minimizes the local concentration in a short time. Multiple stage extraction. Like the normal maceration process, however, extraction is incomplete since mass transfer will cease when equilibrium is set up. This process can be overcome by using a multi-stage process. The equipment needed for this method is a circulatory extractor connected to a number of tanks to receive the extracted solution. Like this. The process is same, but you are getting in your extracted material in a different stages or in different containers. What is the procedure? First, you fill the extractor with drug, add the solvent to circulate, run off to the receiver 1. First, it will go to the receiver 1. Refill extractor with solvent and circulate, run off to receiver 2. Refill extractor with solvent and circulate, run off to receiver 3. First, it will go to the receiver 1, then 2, and then 3. Remove drug from extractor and recharge. Return solution from 1 to extractor, remove for evaporation. Return solution from 2 to extractor and circulate, run off to receive 1. Return solution from 3 to extractor and circulate, run off to receiver 2. Add fresh solvent to extractor and circulate, run off to receiver 3. Remove drug from extractor and recharge and repeat the cycle. Recharge means you're again, separating it basically. Okay. Advantages: the drug is extracted as many times as there are several receivers. The last treatment of the drug before it is discharged is with fresh solvent, giving maximum extraction. What you do after, putting it in the different containers and you again repeating the process with the 1, 2, and 3 collected solvents, the discharged material or your plant material, which is there, it should be, again, should be treated with the fresh solvents. So you get a maximum extraction, because extraction is also dependent upon the solubility, and when the solvent is already saturated with your active component, then it will no more absorb or it no more dissolve your desired product. So after repeating, you're making it efficient. You are basically, because if it has the capability to solubilize your compound, then it will, but maybe it will not. So you circulate your used component again and again until the product is discharged. And lastly, what you do the extraction with a fresh solvent. The solution is in contact with fresh drug before removal for evaporation, giving the highest possible concentration of your active ingredient. Now, what is percolation? Percolation, exhaustive extraction. It is also known as exhaustive extraction. The term percolation, from the Latin word per, meaning through, and colere means to strain. That means through to strain. It may be described generally as a process in which a comminuted drug is extracted of its soluble constituent by slow passage of a suitable solvent through a column of the drug. Basically, it is kind of, the percolators are kind of apparatus which is shown in your right hand side, that the process is kind of continuous, but it's a very slow process. The drug is packed in a special extractor apparatus termed as percolator. The right hand side with the diagram you see is of a percolator. with the collected with the collected extractive called the percolate. The extractive which is there is the percolate. Most drug extractions are performed by percolation. In the process of percolation, the flow of menstruum over the drug column is generally downwards to the orifice, down by the force of gravity as well as the weight of the column of liquid. In certain specialized and more sophisticated percolation apparatus, additional pressure on the column is exerted with positive or air pressure at the inlet and suction at the outer to exist. This, you see the apparatus in which, the herb is basically, it is put inside the percolator over a perforated plate. There is a perforated plate in the container, and you place your drug or you pack your drug basically onto that perforated plate, and then you allow certain liquid in it. And the extraction is done through the gravitational pull, or due to the gravity, the liquid will fall down. And not only because of gravity it is going down, but of course there is a amount of liquid over the herb, so the liquid is also putting some pressure over the herb. So these both forces are applying on the herb, and the extraction is under these two forces. And you can also put pressure on that liquid to go through that herb, and you can make your extraction quicker. Percolators for drug extraction vary greatly as to their shape, capacities, composition, and most important utility. The percolators are not always of the shape which I have recently, shown you in my last slide. It can be of different shape, it can be of different capacities, and you can keep your compounds in different compositions, and most important is the utility. Percolators employed in the large-scale industrial preparation of extractives are generally stainless steel or glass metal vessels that were greatly in size and in operation. Percolation on a small scale generally involves the use of glass percolators of various shapes for extraction of small amount, perhaps about 1,000 grams of crude drugs. This is a commercial scale percolator, okay? Different shapes of percolators: cylindrical with little, if any, taper except for the lower orifice, also called the Orberg percolator. Roundish, but with a definite taper downward, conical or funnel shape. There are different types. The cylindrical percolator is particularly suited to complete extraction of drug with a minimal expenditure of menstruum. The choice in type of percolator, how you choose upon on the different types of percolator are the nature of the drug, type of product prepared, quantity of drug to be extracted, processes and steps of percolation. Preparation of dried crude drug for percolation. Before percolation, we start percolation, we first powder it, we do the moistening, packing the percolator, period of maceration, percolation and collection of percolate, adjustment of concentration of percolation as required. What modification you can done? In general process of percolation, the following problems may arise. If the active substance are thermolabile, evaporation of large volume of dilute percolate may result in partial loss of the active constituents. We all know, we have discussed earlier as well about the thermolabile compounds. In the case of alcohol-water mixture, evaporation results in preferential vaporization of alcohol, leaving behind an almost aqueous concentration, which may not be able to retain the extracted matter in solution and hence get precipitated. Okay. There is another method, reverse percolation. In this case, the extraction is done through the general percolation procedure. At the last, the evaporation is done under reduced pressure in equipment such as that all the water is removed. This is then dissolved in reserve portion, which is a strongly alcohol and easily dissolve the evaporated portion with any precipitation. Now, some other processes in a very concise manner. Decoction. We all know this method involves the placement of plant material in water, then boiling the mixture. It's like, making a tea. Then boiling the mixture for about 15 minutes, followed by the filtration to obtain extractive and removing the mark. Okay, this is simple method. This is called decoction. While indigestion, maceration with continued heating during maceration period, the temperature is between 42 degrees centigrade. And usually in digestion, there is also use of some kind of organic acid in it, so the compound get digested or it ooze out from the compound. Infusion involves first macerating the drug with cold water, followed by the addition of boiling water in an amount equal to 90% of the desired volume. So that's all for today. Inshallah, we'll continue from our next lecture.